Surveying security threats of cloud systems. Finding out what researchers have learned about cloud computing and its critical issues with security, privacy, and the benefits is crucial for clients who are considering adopting infrastructure and platform as a service models. Cloud computing uses the internet to provide on-demand access to programs, server hardware, online servers, archive information, developer resources, and network capabilities. Cloud-based systems offer a viable avenue for providing benefits such as scalability, reliability, efficiency, and decreased cost of data management. Even though cloud service offers business beneficial resources, security, data control, and other concerns have slowed its adoption. Cloud computing has limitations that must be eliminated before organizations can fully utilize the technology with confidence. Our research team has chosen to review papers that survey the security threats of cloud systems. LaShawn Hayes, Ariel Jackson, Gaten Siri, and myself, Anita Robinson Muhammad, will be presenting our survey papers that examine components of cloud computing service provisions and the challenges with security, privacy, and data control. The researches of the literature included in our paper packet also examine countermeasures that address the client and cloud service providers' concerns regarding the safety of cloud computing. Why have known benefits of cloud computing services not resulted in rapid adoption? Despite cloud computing's wide variety of uses, the fundamental reason many businesses have not adopted the service is the issue of how customers and cloud service providers ensure the security, privacy, and confidentiality of stored data, as well as the transfer of the data. The security and confidentiality of data kept in a cloud system in particular offers significant issues that the utility computing paradigm must answer in order to be widely embraced. Since storing data in the cloud system involves a shift in strategy and must take into account and handle all potential risks, the goal of providing a safe and secure cloud platform must be shared by both the cloud service provider and their customers. While conventional computing remains popular, knowing the risk associated with cloud computing is crucial. How was computing before cloud computing? Prior to the emergence of cloud computing, companies had to invest in and run their own servers to satisfy computing demands. Adequate server capacity to handle peak traffic volumes had to be purchased to prevent disruptions and outages. So what is the buzz about internet computing? By migrating to cloud services providers, businesses may save money on costly IT resources, such as hard drives and private data hosts, and they're being replaced in the cloud computing by distant servers that store the data and provide on-demand access. How does cloud computing work? There are three basic implementation frameworks of cloud computing. They're going to be discussed further within the presentation, but I'll just turn these for you. Public cloud refers to a shared and virtual platform cloud for storing and regulating data and application access. A private cloud is a system that is used by just one enterprise. And then there's a third model, which is a mix of the public and the private cloud. And it's also referred to as a hybrid cloud. Cloud computing has some security challenges that are the main focus of a customer when they are thinking about adopting a cloud service. Despite the fact that public, private, and hybrid cloud services use reliable security mechanisms to secure data from unwanted access, many organizations have still been hesitant to use the service. The most often stated reason for firms' reluctance to embrace cloud computing is the threat of data security or cyber attacks. Cloud threats that compromise data accessibility and storage include denial of service, hijacking, malware insertion, and illegal access. Attackers work around the clock to develop assaults while new countermeasures are introduced to safeguard cloud service platforms and the customer's data. Our presentation is going to discuss samples of published surveys on cloud computing and the countermeasures used to enhance cloud service security. There are consequences of unaddressed security issues in cloud computing. Unresolved issues include the lack of a good service level agreement and the correction of problems within the security during development. A study conducted by Accurus, a business that provides a platform for analyzing the security of cloud computing environments, found that 96% of cloud security vulnerabilities discovered during production go unresolved. Surveys cite the consequences that arise from unaddressed security issues to include loss of data, disruption or loss of access to data, corruption of databases, and others. Loss of sensitive customer information results in damage to the company's reputation, which is not good for business or the adoption of cloud service computing. Companies also experience financial losses when they are faced with such consequences. Another unaddressed issue in cloud computing is existence of a service level agreement that ensures cybersecurity safety. According to researchers, another unaddressed issue in cloud computing security adoption is the non-existence of service level agreements regarding cybersecurity. The cloud computing model cannot positively influence cloud computing adoption due to their failure to ensure compliance with their service level agreement regarding cybersecurity. Current service level agreements, the service level agreements provided to the client do not offer a statement that involves cybersecurity.
This is Gaetan Siri, and together we will explore the different types of clouds and cloud services, the major players in that industry, and we will also touch on some of the security challenges for each cloud service. Cloud computing has really revolutionized the way businesses operate. With cloud computing, organizations can quickly and easily scale their operations as needed without having to invest in expensive IT infrastructure. Cloud computing has made it possible for organizations to be more agile, responsive, and efficient. Cloud computing itself is made possible by a range of underlying technologies, including virtualizations, software-defined networking, and automation. These technologies basically allow cloud service providers to deliver computing resources on demand and manage them more efficiently. Cloud computing has also enabled the rise of new technologies and business models such as data analytics, big data analytics, machine learning, and the Internet of Things, and most recently, AI, as you heard in the news. These technologies enable organizations to basically gain insights from large volumes of data and create new business opportunities. However, cloud computing also presents new challenges, such as managing data privacy and ensuring data security, along with complying with regulatory requirements. Organizations need to be aware of these challenges and take appropriate measures to mitigate them. So what are the various cloud types that exist out there? So we have the public cloud, the private cloud, and the hybrid cloud. The public cloud type, what are some of its advantages? So the public cloud offers several advantages over the traditional IT infrastructure. These advantages include high scalability, high flexibility, cost effectiveness, and a pay-as-you-go model. Also, reliability and location independence. Public clouds are highly scalable, which means that organizations can easily add and remove computing resources as needed. Makes it easy for organizations to meet the changing business requirements without having to invest into expensive IT infrastructure. Public clouds are flexible, which means that organizations can choose the computer resources that fit their needs. They offer a wide range of services, including computing, storage, networking, and security, which can be combined in various ways to meet different requirements. They're cost effective, which makes it basically easy for organizations to control their IT costs without over-provisioning things. Finally, public clouds are reliable and location independent. So the cloud service providers typically have multiple data centers located in different regions to ensure that services are available in the event of a data center outage. What are some of the disadvantages of public clouds? One of the main ones is ensuring that data is secure and compliant with regulatory requirements. So basically, there's a lot of work that goes on between the organization and the cloud service providers to ensure that appropriate security measures are in place. The other challenge is lack of visibility. So this is an outsourcing process of the IT infrastructure to a third-party service provider. So organization may not have the full visibility that they need into how their data is being managed or secured. And that can be a concern for some organizations that have strict data privacy or compliance requirements. And then there's the private cloud. So some of the advantages of the private cloud is private clouds are dedicated to single organizations, and they offer greater control over data and security and compliance. So they're best suited for organizations that have highly sensitive data, compliance requirements, and mission critical applications. So one of the main advantages of private clouds is the greater control over data. Private clouds are dedicated, so organizations have complete control over how their data is managed and secure, and that's important for some organizations. So private clouds also offer greater control over compliance. So private clouds are dedicated, again, and organization basically can ensure that their data is compliant with regulatory requirements. This is important for organizations that operate in highly regulated industries like the healthcare industry or the finance industry. However, there are also some potential disadvantages to using private clouds, and one of them is cost. Private clouds are typically more expensive than public clouds. So organizations need to invest into their own IT infrastructure, basically. The other challenge is the lack of scalability. And so private clouds are typically less scalable than public clouds, which means that organizations may need to invest in additional IT infrastructure to meet changing business requirements. Now let's talk about the hybrid clouds and its advantages. So basically, hybrid clouds offer several advantages over both public and private clouds. So hybrid clouds combine the benefit of both public and private clouds. That way, organizations can leverage the benefit of both types of clouds. So hybrid clouds are more flexible. They allow organizations to choose the computing resources that best fit their need, meaning they can use public clouds for the non-sensitive workloads and private clouds for the sensitive workloads. Hybrid clouds also offer greater control over data, security, and compliance. Organizations can keep sensitive data in the private cloud and use public clouds for non-sensitive data. They're also scalable. Organizations can quickly and easily scale their operation by leveraging the public clouds for additional computing resources. So what are the disadvantages of using the hybrid clouds? One of the main challenges is complexity. So hybrid clouds can be more complex to manage than either public or private clouds because organizations need to be able to manage both environments at the same time. The other challenge is data integration. Organizations basically need to ensure that data is integrated between their public and private cloud to ensure that services work seamlessly. Let's talk about the type of cloud services that these environments offer. We have three main ones. So the infrastructure as a service, platform as a service, and software as a service. Let's begin by talking about the infrastructure as a service. So basically, infrastructure as a service provides organizations with access to computing resources on a pay-as-you-go basis. Examples can include virtual machines and storage. Infrastructure as a service is typically used by organizations that need to quickly and easily provision computing resources without having to invest in expensive IT infrastructure. One of the main advantages is flexibility. And also scalability. Organization can quickly add and remove computing resources as needed. As business requirements change, that's important. What are the disadvantages of using infrastructure as a service? One of the main one is data security. Organization, they need to work closely with their cloud service provider to ensure that security measures are in place to protect the data. There's a lot of lack of control because organizations are basically outsourcing their infrastructure to a third-party service provider. And they might not have control over how their data is managed or secure. Platform as a service. What is it? It is a platform for developers to build, deploy, and manage applications without having to worry about the underlying infrastructure. Back then, you wanted to deploy an application, you needed to provision a web service, configuring, it's complicated. Platform as a service makes that very easy nowadays. Developers can use pre-built components and tools to quickly and easily build the application. So they focus on building the app, not on the infrastructure part. That's huge. It speeds up the development process and improves the quality of the final product. Platform as a service is also highly scalable. Developers can quickly add and remove computing resources as needed, which makes it easy for them to meet changing business requirements. What are some of the disadvantages of platform as a service? Basically, vendor lock-in. Organization might be locked into a specific platform, and it might be difficult to switch to another platform in the future. The other challenge is lack of control. Basically, again, when you're outsourcing your infrastructure to another third-party provider, you may not have full control over how the application is managed or secure. Software as a service, what is it? It's basically, so software as a service provides organization with access to software application on a subscription basis. So the customer can focus on using the application, not building it. And the service provider takes care of basically everything else. And the advantage of that is ease of use, right? So what are the disadvantages of that is data security. Organizations need to work closely with the service provider to ensure that security measures are in place to protect their data. Lack of control, again, you outsource your software to a third party, you may not have full control over how the data is managed or secure. What are the major players out there in the cloud computing world? So we have Amazon Web Services, AWS, Microsoft Azure. These are the top cloud service providers out there. And then you have other ones like Google Cloud and IBM Cloud that are trailing behind. Organizations need to carefully evaluate their needs and choose the cloud service provider that best fit their requirements. The important factors to consider: cost, scalability, flexibility, security, and compliance. So what are some of the security challenges that exist in the cloud computing world? So they vary depending on the type of cloud service that's being used. Public clouds present some challenges, such as the lack of visibility, mostly. And from the private cloud, some of the challenges include insider threats, configuration errors, and basically compliance issues. So organizations need to basically implement appropriate security measures to mitigate these risks. Hybrid cloud also present challenges such as data integration, compliance issue, and complexity. Other security challenges in the cloud include managing data privacy and ensuring data security, along with complying with regulatory requirements. So organizations need to be aware of these challenges and they need to take appropriate measures to mitigate them. These may include implementing data encryption, access control, and monitoring tools.
Going into security threats of the cloud, it can be described as a cyber attack that targets cloud-based service platforms such as computing services, storage services, or hosted applications in the cloud. When developing security systems, it's very important to follow the CIA triad model, as it is used for finding vulnerabilities and methods for creating solutions. The CIA triad stands for confidentiality, integrity, and availability. Confidentiality ensures that information is accessible only to those users that are authorized to have access. Integrity protects against the accuracy and completeness of information and processing methods. Availability ensures that authorized users have access to information when required. When all three standards are satisfied, the security of the cloud is protected from attackers. However, there are times when attackers are able to invade the system, possibly breaking one, two, or all of the triad standards if the attack is advanced enough to break through the cloud security system. In the following slides, I'll be describing some common cloud threats and a few protection methods for the threats. You guys will notice that a lot of the protection methods are repetitive, that give us the protection methods that we need. There are three categories of threats. There's information, network, and cloud environment threats. First, we're going to be looking at information threats, starting with data breaches. A data breach in the cloud refers to the unauthorized access or theft of sensitive information that is stored in cloud-based systems, applications, or services. This can happen when cyber criminals gain access to the cloud infrastructure through various means, such as exploiting vulnerabilities in the system, using any stolen credentials, or doing phishing attacks. Once a data breach occurs in the cloud, sensitive data such as personal information, any financial data, or intellectual property can be stolen, leaked, or even sold on the dark web. The consequences of a data breach can be severe, including financial losses for a particular company, legal liabilities, or damage to brand reputation as well. To prevent data breaches in the cloud, it's very essential to implement very secure and robust security measures, such as multi-factor authentication, encryption, access controls, and regular security audits. It's also really important to educate users of the cloud and any employees about safe cloud usage and practices, to also stay vigilant against any potential threats that could happen. Next, we're going to talk about cloud data loss. Data loss refers to the unintentional or accidental deletion, corruption, or loss of data that is stored in cloud-based systems. This can happen due to various reasons, such as human error, system failures, software bugs. When data loss occurs, it could lead to very significant consequences, such as data loss, of course, service disruptions, or business interruptions. It could cause a range of problems, such as the inability to access any important information, the loss of important files or records, and also possibly damaging the reputation of the company or business. To prevent cloud data loss, it's important to have backup and recovery strategies. This can include things such as multiple backups of critical data regularly, and also storing them in secure locations, both in the cloud and also in on-site servers. You want to make sure you do regular testing of any backup and recovery processes that have been implemented. Our last in information threats are going to be cloud advanced persistent threats, or APTs. This is a type of cyber attack that involves targeted, prolonged hacking campaigns aimed at stealing sensitive information from the cloud. They're generally very complex attacks. They pretty much remain in the system undetected for long periods of time, allowing the attacker to gain valuable information from the cloud using various techniques such as implementing malware or any social engineering, phishing attacks. Once they're into the system and have enough time to gain what they're looking for, they could grab information such as financial information, intellectual property, or any personal identifiable information. To protect against APTs, it's important to use multi-factor authentication, access controls, encryption, those similar things that we talked about earlier. It is important to train employees and administrators on safe cloud usage and to also remain vigilant against any threats that may happen. Next, we're going to move into network threats. The first network threat we're going to talk about is cloud account hijacking. This refers to the unauthorized access or takeover of a user's cloud account. This can happen when attackers gain access to user login credentials through various means such as phishing or any malware. Once the attacker gains access to the user's account, they can access any sensitive data, files, or any applications that are actually stored in the cloud account. Cloud account hijacking can cause significant damage to the user and the organization. There could be financial loss, reputation damage, and also the loss of sensitive data. For prevention methods, similar things we talked about as well: multi-factor authentication, implementing password policies, and security monitoring, regular security monitoring. Our next is going to be Cloud Distributed Denial of Service, or DDoS. This is a type of cyber attack that aims to disrupt the availability of the cloud system. And it works by overwhelming the system with heavy traffic from multiple sources. DDoS attacks are often carried out by botnets, which are networks of compromised computers that are controlled by the attacker. These can also cause significant damage to a system, including, of course, service disruptions where you are not able to use the system, downtime, and again, financial losses. Prevention methods would be regular traffic monitoring, seeing just how much traffic, making sure there's not any unusual heavy traffic happening, and access controls. Next and lastly, we're going to talk about cloud malicious insiders. This refers to individuals who have authorized access to a cloud system, and they intentionally misuse that access for personal gain or to cause harm to the organization. This can include things such as stealing sensitive data, compromising cloud security controls, or disrupting the cloud services altogether. Malicious insiders can be any employees, contractors, or any partners who have access to the cloud infrastructure. They have inside information where they're able to get in and move around freely to collect what they need. To prevent these type of threats, it's important to include identity and access management, segregation of duties, and privilege access. When employees are no longer using that particular cloud system, it's really important to make sure that they no longer have access after they have been removed from those using those services. Our next threat is going to be cloud information threats, and we're going to look at abuse of cloud services. This refers to the use of cloud infrastructure, applications, or any services for malicious intent or any purpose. This can include launching cyber attacks, distributing malware, or hosting illegal content. Abuse of cloud services can cause significant damage to the cloud provider or any stakeholders of the cloud. It can result in any reputational damage and sometimes legal liabilities as well when the cloud is abused. There needs to be strong security measures put in place so no abuse is able to happen. The same prevention methods as earlier, including access controls, that traffic monitoring, and security incident response plans. There needs to be regular security audits as well, and to identify and remediate any vulnerabilities that can be exploited by attackers. Next, we're going to look at cloud insecure interfaces and APIs. This refers to vulnerabilities in the communication channels used by cloud-based services. These vulnerabilities can be exploited by attackers to gain unauthorized access to cloud resources, compromise data integrity and confidentiality, and cause service disruptions. Insecure interfaces can happen for several reasons, some including weak authentication and authorization mechanisms, improper input validation, and insufficient encryption and transport security. Prevention methods, there needs to be secure coding practices, performing of regular security assessments, and using secure communication protocols at all times. Our next threat we're going to look at is weak identity, credential, and access management. This refers to vulnerabilities in the processes and technologies used to manage and control access to cloud-based resources. This can result in unauthorized access to cloud resources, data breaches, and other security incidents. This can happen due to various reasons, including having weak passwords that can be easily guessed, inadequate authentication and authorization mechanisms, and insufficient user and identity management. To implement implementing prevention methods, you would need strong access controls, and again, that multi-factor authentication, role-based access control, and least privilege access. In my next slide here, I wanted to discuss one of the leading cloud providers today that we have globally, which is Amazon Web Services, or AWS. AWS is one of the leading cloud providers that we have globally. They have significantly more services and features, and those features within those services are very large. There are millions of customers and thousands of partners globally. With as many features and services that AWS has, they have a good amount of security protocols in place to keep the cloud secure and continue meeting the business demand for a successful functional cloud system. There are several methods that have been implemented to protect their cloud system, such as general security measures, infrastructure security, and protection of stored data and transmission of data. For example, a few methods, security methods that they have in place right now are for network security. They have a multi-tier network architecture that segregates the network traffic and prevents unauthorized access to any customer data. Also, they have monitoring and logging. AWS provides customers with tools for monitoring and logging of the infrastructure and applications. So that includes, they have Amazon CloudWatch, which provides that monitoring and logging services. And they also have Amazon CloudTrail, which provides an auditing system and event logging for any users that are using the system to track their movement. Another security method they have is encryption, of course. They use encryption to protect data when it's stored and also when it's in transit. They encrypt their data using AWS key management services. And also, they also provide identity and access management. This allows customers to create and manage user access to control the resources that they are providing in the cloud.
Hello, my name is LaShawn Hayes, and I'm here to talk to you about countermeasures to cloud security risks and attacks. The evolution of cloud computing has caused an increase in security risks, threats, and attacks. While using cloud computing has simplified some jobs, it has also brought up new safety issues and concerns. There are a significant number of vulnerabilities that can be exploited by malicious actors due to different types of data scattered around the network and stored in a variety of cloud services. Some of these vulnerabilities can include malicious insiders, data breaches, data loss, malware, distributed denial of service attacks, and hijacking, among others. Although cloud security measures exist, there is an inherent need for more advanced cloud security procedures and practices. Maintaining the integrity of the content and preventing unwanted access are major objectives of cloud security. Yet, these objectives are sometimes difficult to achieve using conventional tools and methods. In order to safeguard the cloud and preserve an organization's data, it is necessary to utilize the appropriate countermeasures to cloud security risks and attacks. Types of countermeasures. Keeping the cloud environment safe requires a plethora of diverse defenses. Encryption methods, multi-factor authentication, access control, data security audits, firewalls, data mining techniques, classification and clustering algorithms, honeypots, intrusion detection systems, and additional countermeasures are all examples of cloud security defense measurements. In this portion of the presentation, I will review some of the most commonly employed countermeasures, as well as the problems and solutions to them. I will also examine a case study in which a system was created to act as a countermeasure to help prevent cloud security issues. Access control. Access control is a security system that consists of identification, authentication, and authorization. It is a means to ensure that only authorized users are granted access, guaranteeing that the data is retained securely. Access control is carried out by authentication processes, including IDs, passwords, and PINs. Now, there are a variety of access control systems, such as MAC, Mandatory Access Control, DAC, Discretionary Access Control, RBAC, Role-Based Access Control, and ABAC, Attribute-Based Access Control. However, these systems have been challenged with the evolving, sophisticated nature of cloud computing. They have occasionally been shown to be ineffective. The solution to this issue is to enhance the access control security systems with an extra layer of security by adding multi-factor authentications, access control list, or identity access management. Multi-factor authentications combine the traditional authentication factors and other factors, including inherence, location, and time. Access control list allows for strict monitoring and reporting on who has access to critical resources. Identity and access management focuses on providing security as a cloud service and encompasses a variety of technologies, including reporting and monitoring tools, provisioning tools, identity repositories, and security policy enforcement programs. Access control is most common measurement to address the issue of leaked data by hackers or cloud internal managers. Encryption. Encryption is a countermeasure for resolving data confidentiality challenges in cloud computing. Sensitive data is protected using encryption methods so that people with the access to encryption keys may decrypt it. Encryption is a technique of turning plain text data into a string of unreadable code, ciphertext, that requires a key to be used successfully. AES and RSA are the most widely used encryptions. Now, encryption alone does not always guarantee protection from attacks, so the solution to this issue is to add the usage of honeypots. A honeypot is a fake system used inside fully operational networks and servers that are frequently used as part of an intrusion detection system. They divert criminal attention away from the real system while evaluating hostile activities to assist in the mitigation of vulnerabilities. Network security firewall. A firewall is a network security countermeasure used to protect data in motion. It filters packets entering the cloud service provider's network and serves as an early warning system for suspicious activity. Firewalls help to eliminate vulnerabilities and prevent backdoor Trojan attacks. However, they are not ideal for preventing cloud service attacks or eliminating viruses, worms, or malware. The solution to this issue is the usage of an intrusion detection system, IDS, and/or an intrusion protection system, IPS. IDS is the most popular method for identifying different cloud attacks and is used to track client strategy violations, assess the reliability of documents and systems, monitor unusual activity, and examine traffic or content that could jeopardize the security of a system or computational resource. IPS is a network security monitor that helps to prevent intrusion or ransomware, in addition to detecting and tracking risk. In order to detect and prevent the compromise of cloud resources, IDS and IPS are essential security mechanisms that will notify users of any suspicious behavior. Cloud Matrix Case Study. The ability to identify risks, threats, and attacks and vulnerabilities in cloud computing systems is paramount. Early detection can mitigate a threat before it becomes harmful and result in a dangerous situation. One of the case studies within our research papers promoted a cloud control matrix as a solution to this issue with cloud security. Cloud Control Matrix is a framework created by Cloud Security Alliance that helps cloud service providers and cloud service customers manage risk. The researchers in the paper chose 26 risk, threats, attacks, and vulnerabilities listed on a table and mapped them onto the CCM to assess the effectiveness of the security controls. The risk, threats, attacks, and vulnerabilities that were chosen from the list, along with descriptions of each control, were read. The security controls that can reduce risk were then chosen and analyzed to ensure that they were sufficient measures to mitigate or partially mitigate the risk, threats, attacks, or vulnerabilities. Implementation instructions for the control specifications for each of CCM Volume 4's 17 cloud security domains were considered when mapping the 197 security controls. The study found CCM to indeed be effective, and many businesses and organizations have already begun using the framework. According to the research analysis, the most effective domains of the CCM for managing cloud-related risk are security incident management, e-discovery and forensics, data center security, logging and monitoring, supply chain management, transparency and accountability, and threat and vulnerability management. It is recommended that businesses give adequate attention to adopting any of these domains within their operations.
In this next section of our presentation on surveying security threats of cloud systems, we will talk about some of the papers that we've reviewed as part of our research. The first paper, entitled Adoption of the Cloud Control Matrix Framework for Effective Measurement of Cloud Risk, Threat, Attack, and Vulnerability, revolves around the Cloud Control Matrix, CCM, and its application in measuring and mitigating cloud security risks. The CCM is basically a set of security controls that are intended to aid consumers and providers in assessing cloud security risks and ensuring compliance with security standards. The CCM is composed of 17 cloud security domains, with each domain containing several control specifications designed to address security concerns. So the pros, after reviewing the paper, the pros of the paper that we found out were useful. It basically provides insights into the Cloud Control Matrix framework, CCM. And that framework can help organizations better understand and manage cloud computing risks, threats, attacks, and vulnerabilities, which is good. The cons of the paper: it does not cover all the aspects of cloud computing, security, and risk management, as it specifically focuses on the CCM framework. Another paper that we reviewed, the title of the paper is A Survey on Security Threats in Cloud Computing Services Models. That paper focuses on cloud computing architecture, which consists of basically a front-end component where the customers communicate with the cloud service provider, and a back-end component where the service provider manages all the resources required to deliver the cloud computing services, and provides an overview of the three main service models in cloud computing: SaaS, platform as a service, infrastructure as a service. The paper highlights the need to assess and mitigate risks in cloud computing. It provides an overview of open issues and risks, along with preventative measures such as multi-tenancies, data encryption that must be implemented to secure the cloud computing platform. So that was all good. The paper highlights several security concerns and provide practical preventative measures to mitigate the risk. The preventative measures suggested in the paper are well researched and could be useful for companies looking to secure their cloud-based systems. The cons of the paper. The paper does not provide an in-depth analysis of the potential limitations or drawbacks of the suggested preventative measures. The paper could probably benefit from a more critical analysis of the current state of the cloud computing and how it may evolve in the future. Another paper that we reviewed was a case study, basically, a study of security threats and attacks in cloud computing. The paper specifically discusses the security measures taken by Amazon Web Services, one of the major providers of cloud services. It highlights that Amazon Web Services integrates security into its services and provides a shared responsibility model between the client and Amazon Web Services in the process of migrating IT infrastructure into AWS. AWS uses several measures to safeguard cloud infrastructure, including certifications, accreditations, PCI data security standard certification, defense information assurance, and accreditation program with operating authorities authorization. The paper emphasizes on the importance of security best practices, including the implementing security at every tier of the cloud application architecture and utilizing specific tools and features to safeguard the AWS cloud applications. The paper also discusses the challenges and issues in cloud security, such as the risk associated with multi-tenancy and the need for a reliable access control system to prevent unwanted access to shared pool resources. So the pros of the paper basically provides a comprehensive overview of the security challenges in cloud computing, and provides guidance on how to address them. It provides a very practical example of how a major cloud service provider implements security measures. We're always looking to follow best practices, so this was a great way to know what the major players out there do to mitigate some of these risks that are out there. The cons of the paper: it is quite technical, and it may be difficult for non-experts to understand. Some of the content may also become outdated over time as technology and security threats evolve. And the paper probably does not delve deeply into the economic or social implications of cloud security issues, which could be relevant in some contexts.
Researchers have identified health information management and the Internet of Things as two areas of future direction in cloud computing. Hospital organizations are adopting cloud services to manage health information and healthcare record storage. Hospital organizations' concerns regarding cloud computing adoption include data security, confidentiality, access control, shared data, integrity, and internal attacks. Combining the Internet of Things with cloud has resulted in a new global computing paradigm known as the Cloud of Things. The cloud of things involves a network of connected devices and the technology that facilitates communication between devices in the cloud. The cloud of things has given rise to the use of Fog Cloud. Fog Cloud is a decentralized computing infrastructure in which data, computing, storage, and applications are located between the data source and the cloud. Fog networking helps the idea of the Internet of Things in which most of the gadgets people use every day are linked to each other. Examples are mobile phones and personal health trackers. After reviewing our chosen survey articles, we concluded that businesses are increasingly using cloud computing since the advent of this cutting-edge technology. However, the danger landscape has risen substantially. In this research, we examined the risk of cloud computing and the precautions that should be taken to protect users. The three most common implementation strategies include public cloud, private cloud, and hybrid cloud, which is a mixture of the public and private cloud. For understandable reasons, many businesses have hesitated to use the service due to concerns about data security and cyber attacks. Research has revealed that 96% of cloud security flaws discovered during production are never fixed. Organizations are wary of using the service since there are no security assurances in the service level agreement. Based on the literature review, we determined that the confidence in cloud computing necessitates research into the threat posed utility computing systems, the development of cybersecurity policies, the implementation of general countermeasures, and identification and resolution of security deficiencies will facilitate the improvement in confidence.